Okay, good morning all. I am Vijay Jethani. I'm Cloud Solution Architect at Microsoft. So for today's session, we are going to cover the concepts on modern data warehouse. Okay, so we will look at, as per the agenda, we will first of all cover what are the components, what makes up the modern data warehouse. Okay, with building on that, we will go through why we actually need the DevOps for modern data warehouse. And once we know that we need DevOps, then how actually DevOps helps modern data warehouse is what we will look into. And finally, we will look at the native tools, because once we talk about modern data warehouse, there will be n number of tools you will be going through. And to know all those tools or whatever tools we are talking about, we should actually have some brief about that, how to go about that, what that tool does, and all those things. So from a DevOps perspective, as well as modern data warehouse perspective, we need some base understanding so that while we do the future sessions on hands-on lab, we have sufficient knowledge, or I would say a concept driven architecture design and implementations in our all the sessions, so that we can run that through and actually implement those modern data warehouse implementations on our own. Okay. So similarly, if you see the session takeaways, we need to know each and every component, what makes up the modern data warehouse. Similarly, why we need DevOps is also something which we have covered in our previous sessions from the DevOps perspective, like all the components of DevOps. But here we are looking more towards why DevOps, especially for modern data warehouse. Okay. Another thing is, obviously we are working towards modern data warehouse, so we need to understand what that pipeline architecture for modern data warehouse look like, or why we need that particular. So that is how the session takeaways will be. Similarly, at the end will be complete deep dive of that particular architecture, how that looks like in a modern data warehouse implementations, and how the DevOps is bringing the value to that. Okay, so those will be the session takeaways. So as I said, this will be a concept session. We will only have concepts so that when we come on next month for the hands-on lab, we are able to do end-to-end implementation using DevOps for that particular modern data warehouse. Okay, so that all will be the upcoming sessions in the next month. Okay, so 15th and 22nd Feb we'll be doing those hands-on labs for this modern data warehouse. Till the time we will have also have some the backend knowledge about what we are trying to do. And in meanwhile, if someone is new and trying to learn about modern data warehouse, they will have sufficient time to get those concepts ready. Okay, so now let's get started with the modern data warehouse concepts. So first of all, before we even drill down into modern data warehouse, first of all, why we need a warehouse at first place is the questions or query you have to ask yourself. So what we have in a production that is catering to business users and providing the business to n number of whatever particular stakeholders, or I would say the business users are using. Okay, so that is how that particular production environment is critical for us to run our day-to-day business. But from the warehousing or analytic purpose, we need some way to run some analytics on top of that. So that is the reason we want to separate a production environment from our warehouse environment, or in our case, we would say modern data warehouse environment. Okay, so let's understand from the analytic perspective, what kind of analytics we have at present. So if you see from left to right, we have a different type of analytics. Okay, now a simple example I can give you, many of us might be using log analytic workspace or some kind of workspace where we keep our logs. The logs can be application logs, logs can be any of the diagnostic logs, it can be anything from which we want to derive a value using queries or some kind of analysis on top of that. Okay, so if you are dealing with what happened, then this is called descriptive analytics. If you are looking for why it happened, then obviously we are looking at diagnostic logs simple example can be any application crashes. And if you have already using Azure, I think you know log analytic workspace and a similar kind of a workspace environment which you might be using for your on-premise environment as well. So that is how actually we deal with those particular analytics day to day, right? Descriptive and diagnostic. So till here, I think we are pretty much there. Let it be an on-premise or let it be our cloud environment. But modern data warehouse goes beyond that. Okay, so it goes for prediction analytics. Now, why that is useful? The prediction analysis is useful for us. Like say some a simple example I can give you is, say suppose you have any IoT devices placed at the remote locations where you cannot reach, but you need information about the sensors, what is the temperature there, all those things what you can think of. Similarly, any production machine or any production industrial environment where machines are running continuously 24/7, you really need to know about their information or data from their sensors, how they are performing, so that based on this predictive analytics, we can do the prescriptive analytics. Now, what is prescriptive? Is to know how I will actually repair that or maintain that in a future. Say suppose if it is going from my prediction, it or from the diagnostic, descriptive, all whatever I have been doing through, I can predict that this particular specifically component or part goes off in 2 years, 3 years. So I know the lifetime of what it is capable of. So based on that, I can have the prescriptive analytics based on that. Okay. Now this can involve machine learning. This can be done without machine learning depending upon the use case which we are working through. Okay. So the complexity of that modern database environment decides till where we are going through this particular chain. Also, one thing, if you see the information what we get from this data, so if you see the y-axis, it gives you the value. Similarly, if you see x-axis, gives the difficulty of how the implementation is about modern data warehouse or that particular warehouse. Now, to bring those whatever the analogy we have here to a terms related to traditional warehouse and modern data warehouse. The two first buckets which you see from the descriptive as well as diagnostic analytics, those are for your traditional data warehouse, where you have a limited way of actually moving them, some kind of logs, getting them diagnostic, anything which we do in our day-to-day life to keep our environment, machines, or whatever you can say, platform ready running. So you can call this as a data warehouse because that is obviously the different management system we are using for monitoring and managing those particular logs, right? So that is the traditional data warehouse. But if we really want to have a prediction analysis, while in case of an IoT and n number of use cases, I can go through on and on, providing you the like why we need predictive. Similar is case for any manufacturing industry, your automobile industry. If we want to schedule a car maintenance, if we know already what particular the tenure of those components are, or what is the wear and tear of those components, we can obviously have, based on our prediction, we can have the prescriptive analytics on top of that. So as I said, it can involve ML. It can be without ML depending upon what use cases you are working through. Okay, so this is the basic analogy of traditional data warehouse against modern data warehouse. Now let's try to put in a proper fashion how this data warehouse looks like. So if you see a traditional data warehouse, you might be working with your databases, you might be working with some file structure, some data in some structure or a digital format. Okay. So with that, what we do is we try to make them or extract them or export them, whatever name you can say, to some staging environment from where we can actually fetch them or use them for any query analysis, for some analytics on top of that, so that we get value out of it, which we call as a data mart. Okay. So similarly is for a cube, that is nothing but the implementation of these different data marts. Okay. Nothing more about that. Okay. So that is all you see in a traditional data warehouse. You have some source, you know how to bring them to a staging environment and run some kind of query or analytics on top of that. So that is what we call our traditional data warehouse flow. Okay. So everything here the data mart which you are looking here is prepared for an end environment for or I would say an application to accept that data in a format which it is capable of reading. Okay, so there can be n number of formats for which you can provide this particular data, and similarly it can be semi-structured, structured, whatever way you can think of from the analytics or from the data driven decisions of that particular application, including your charts, dashboards, reports, everything whatever you can think of as of now. Okay, so data marts are nothing but ready to use the data for your business users. So how that is different from how our modern data warehouse is different from a traditional data warehouse flow, because here we were very much limited to warehousing only. We were not having any engine as such to run the analytics or do the big data or complex querying on top of what we had in our traditional data warehouse. Now coming to the modern data warehouse, here you have first of all n number of sources. It can come from anywhere, let it be a social environment, let it be an IoT environment, or an n number of varied semi-structured, structured, unstructured data from where we want to derive value. So left hand side you can see these particular datas are providing the value based on, or the data which we are fetching is nothing but your ingest cycle. Okay, so that we know how we want to bring this particular data in, and based on how we bring the data, we query on that particular data. But remember again, the backend layer is a kind of a warehouse where in this case the data like some kind of data like solution or storage, any environment where we want to keep it separate from production, because that is the main use case. We can't run these queries or complex operations on your production environment to keep it running for the production business use. Okay, so that is the reason we want to run any analytics separate from the production. Okay, now coming to the exploration or preparation engine. Like as I said, in the traditional warehouse, there is no as such engine. It is more of a transformation of the data in one shape or format without actually doing any the big data analysis kind of work. Okay? So here we need analytics engine because we are running with n number of workloads. Okay, so complexity can vary, the data size can vary. Similarly, depending upon the data format as well, for us to prepare, we need some compute. Okay, so that is where the analytics engine come here. Similarly, if you see the serve purpose of data warehouse is nothing but what we are talking here was of the data marts. So this serve purpose can be directly used for BI and reporting, which is kind of ready to use as a data mart for consuming as a dashboard, as a report. If not, then the other use cases can be if I want to run some ML or something or machine learning on top of that for advanced analytics, I can do that. Similarly, real-time analytics can also be helpful for any real-time changing environment like any of the IoT's devices. So you want to monitor any particular shafts. So those kind of analytics directly come or use the data marts which we produce from this modern data warehouse as a component. Okay, so this particular service, modern data warehouse as a complete flow, is bringing n number of data first of all. Then we have some kind of engine or some kind of way to bring this in a flow where we can not only ingest, we can explore, prepare, and serve that. So this particular process is called pipelining. Okay, so while I go further on the concepts, you will understand what is exactly the modern data warehouse pipeline and how that is built around. But as of now, just understand the terminologies. Then we will put the name to this each and every particular component what we have in pipeline in terms of the Azure services what we are trying to implement. Okay, now here we just gone through a basic of analytics, and then we looked at traditional data warehouse and modern data warehouse. But what exactly, in a layman's term, what these processes look like and what we do with those processes. So we call this process which you are seeing in these boxes ETL, okay, or ELT. Now let's start with ETL first. So if I extract the data from the source can be anything again, and then I use the transformation engine and load into target. Okay, so this is what is the ETL process, which we do quite often. We also call is a pipelining or workflow process in some use cases. Okay, so this is what we do. Now here, if you see, what we are doing is we are extracting from the source, transforming it in some kind of transformation engine and loading it. All components are separate. That means they are individually handled by the respective services. Okay. However, if we talked about the ELT process, the load extract after load is actually happening within the service where we actually transforming that. Okay, so these are the two processes which you will look like, or the pipelining which you will look like, or the way we deal with this data. So you can do the extract, transform, and load. All are disjoint or are all independent of each other using separate services, or you can combine transform and load into one depending upon the capability of your warehousing system. You can combine the load and transform. Okay, so that is how that differs. Now I've also mentioned few of the services to give you some know-how of what that looks like, or which are the services which use these processes. So Azure Data Factory use this particular ETL process. Similar is for Azure Snaps pipeline. And if you are working on on-premise environment still, then obviously SQL Server integration service you will might be very well aware of. Okay. Similarly, to talk about ELT process. So you, as I said, this requires a loading and transformation to happen on the compute which is powerful enough to do that kind of work. So obviously we need clusters. So that can be a Hadoop cluster with Hive or Spark. Similarly, we can also have the warehousing, okay, secure data warehousing on dedicated pools, serverless pools. Similarly, again, the base end layer for us is on the SQL Server integration services. If you're still on on-premise and hybrid, it is still a useful service which does heavy lifting on the modern data warehouse as on date today. Okay, it is limited to what it can fetch through, but still it is a valid analytics service for us from a modern data warehouse perspective. Okay, so these are the processes which you will hear quite often while you do this modern data warehouse. Okay, so ETL and ELT. The difference is based on the capability or transformation capacity of that particular compute or analysis which you are driving through. Okay, and the services also I've mentioned, it's factory, snaps, and SQL integration service. Similarly is for ETL processes, more of a cluster environment which has huge compute for you to actually drive that load and transform within one particular service itself. Okay, now as I've been talking through this ETL and ELT, what that looks like is called the pipeline or the workflow. So here each and every task which you see here, okay, will have the dependency on how, or I would say source and sink kind of thing. How do I source? How do I sync that? Okay, so those are the terminology we'll use quite often. So if you see the data flow task at right, it's showing you from where you take, you transform it, and you provide the destination. So we call it the source sink kind of an architecture. And the control flow is nothing but your pipeline. It in a sequence, in a parallel, that is purely dependent on us, how we want to run the analytics on top of that particular data which we are trying to derive. Okay, so for modern data warehouse, this is what it goes through as a pipeline. So this pipeline can be within factory, within snaps, whatever services you have been going through, or if you have been working on that, I think you know that. But if you haven't done that, I think just keep as a simple that this is something which is internal to what we do for getting the value out of that data. Okay, so pipelining use is to a kind of a workflow which derives the value from the data. Okay, so that is what you just have to keep it simple from an understanding perspective. Again, the services which use the data pipelining, data factory, snaps, and SQL integration services. Now, this whatever we have covered from an analytics perspective or the analytics use case which you have seen, right? Based on this, okay, modern data warehouse or traditional data warehouse, or how that fits into the today's modern warehousing capabilities and the processes which you are using. We have to make sure which specific computes will be helpful for us. So for that, I think we are bringing the model, or I have to select the model, which is nothing but SMP, which stands for symmetric multiple processing, or massive parallel processing. So if you see this diagram, SMP is having a processor, or I would say one particular machine which is running a number of cores for that particular processor or CPUs, and they are sharing the memory as well as IO, or I would say an operating system for that system. Okay. Similarly, multiple or massive parallel processing is based on the scale out infrastructure, where I have the different nodes running those particular operating system based on whatever compute I want or a big data analytics I want to run, and it has to make sure that it is able to do that job parallelly. Here the jobs, whether they can be done parallelly, purely depends upon the capacity, or I would say it purely depends upon how much we can scale up that infrastructure. But here there is no limit as such, because we are scaling out. So that is called the massive parallel processing. So these are some terminologies which you will hear quite often from modern data warehouse end to end. Okay. If you understand this perfectly fine, then it will be very easy for you to implement those in practical implementations or select as respective components. Okay. So from the concept perspective, for modern data warehouse, that is all you need from an concept per se. Now let's look at, as we are going through that each on every have you gone through that concepts of modern data warehouse. Now let us look into why we need actually the DevOps for this particular modern data warehouse. Okay. Also, for this SMP and MPP, I have just written what services are falls within that category: SQL database and SQL server and a virtual machine. Similarly, any clusters or Spark pools, SD Insight, Databricks, all files are part of your MPP model. So wherever you see the cluster or scale out infrastructure, that is following your massive parallel processing. So let's see why we actually need the DevOps for modern data warehouse, right? So now previously in our concept slides, I was just showing you through the modern data warehouse and how the pipelining looks like. But here, if you see, now I have put across actual services which are representing each and every particular module, from ingest perspective, data factory, from explore perspective, Databricks and warehouse. Okay, similarly, prepare and train, I'm using some kind of cluster. So the symbol represent for the Databricks. Similarly, the other symbol in prepare and train represents the SD Insight. Similarly, is your serving model, which is nothing but your data warehouse, which you are looking at completely right. Okay, so it can be anything, how we want to serve that. So I'm just representing this model exactly the same way, just representing with which services make up those particular modern data warehouse. Okay, and at base I have the Azure Data Lake Generation 2. The difference between this is a normal blob storage does not have a hierarchical system, but with this Data Lake Generation 2 or storage which we create with the generation 2, it gives an hierarchical system. That means you can now have the folder and the file structure the way you used to work in our traditional DFS or file share environments. Okay, so that is what is an advantage of what we are getting here. Okay, so baselining, obviously for warehouse we need something. How we do that is changing depending upon how we are using this particular, or from where we are fetching and what are our end systems. Okay, now again, if I want to drill down and deeper into this and show you the pipeline architecture, this is how it will look like. Now each of the layer, while I'm pulling this from any web service on an API, this pipeline architecture has to first put in a landing zone exactly the same data what it gets from the source, or I would say raw data. Okay. Similarly, with the help of those computes or analytics engine, here in this case is Databricks. I'm using the cleansing and standardizing that data and putting the bad data here. Similarly, clean data I'm putting in an interim container. Okay. And depending upon that interim, I'm just presenting this as a data cube for a consumption to a data warehouse, which is now available for me to provide to a business user in form of a report, in form of a dashboard. But if I'm still running on, or I want to still go ahead and see the value output using some machine learning or something on top of that, I can also involve data scientists. So this is the pipeline architecture end to end, what you are doing from a modern data warehouse. Again, this orchestration layer which you see is nothing but your data factory. The symbol which you see here is the data factory symbol. Okay. Now here you will also have the analytics as a service as well in a lot of the architecture diagrams. But to make it simple, I just kept it so that you understand the component first, and then we deep dive into actual implementations. Okay. So just to show you the representation, how the flow look like, and then actually pipelining work. That means who is doing actual that work. So you should understand component by component before we can implement that using DevOps. Okay. Now we have seen this. Okay. So again, question is why DevOps, right? So if you see the components which we have to do, they are not the like they are not small, or I would say they are not the few components. There are n number of components which play depending upon the data we are moving from here to there. So what we call in the data ops term is this is the data pipeline. That means I get some data, I do from the production system, or and I want to drive some value out of it. I know that I have to move this out to warehouse, which I'm again considering the production. But if you see, it is not possible for us to actually derive the value directly in the production, because it may again be a problem for a user if we are directly doing at the production environment. Similarly, while our developers or n number of things which we do quite often on the application building, similarly on the n number of IoT environments, we need a different environments. Okay, so the first use case which I would say why we need DevOps is, first of all, your environment itself, right? The development, your staging, your pre-production, your production, those all things. That is the first use case to look at why we need the DevOps. Second thing is, if you look the complexity of implementing these all services on your own for these particular environments and keeping them exactly same, or I would say a no touch environment in the production, is quite complex, and it requires a lot of efforts to make that happen. So that is the reason we, again, the second thing which I want, we need a DevOps for that. Okay, so to keep it intact. Now going towards to the innovation pipeline. Now one is a value pipeline which you get from the data ops as a pipeline. Okay, other thing you see is an innovation pipeline. That means it gives us way to put every environment exactly the same way, putting the data what we need, doing n number of test use cases, let it be the unit use cases or let it be the functional use cases. We are able to run them end to end with just one implementations. That particular is replicated across to different environments. So that is what is the value of DevOps here. Now, if I drill down further, this is how the look and feel will be. You will have some kind of DevOps pipelining, which does this work for you, getting a right package built for you, getting the right value out of your data. Similarly, where that data has to be deployed, whether the data or whoever is working in the development environment is available for fetching, or do we have a right approvals in place? Do our functional testing is over? Do our unit testing is over? Those all headache which you get right from getting the data to getting the value out of it. DevOps help us end to end. So I have just put across a just functional diagram of this, like the way you build artifacts are similarly. If you want to run QA testing, you can get through with the help of DevOps. You don't need to repeat that or do it, even if the engineers who are joining new, they just have to rely upon whatever your design or whatever your DevOps code was to just run those particular pipelines and get a relevant artifacts out of it. Similarly, if you want to replicate this complete environment, we call this as a publish part. So we publish that in a different environment from staging to production, exactly the same the way it looks like while we were actually building those particular systems. So this is the value a DevOps brings for modern data warehouse. Now, whatever we have talked so far, right from this particular pipelining structure and doing who does what particular job and what are the components involved, and then looking at value pipeline and innovation pipeline, and finally looking at this DevOps innovation. Okay. Now, these are some of the challenges which put across from the data warehouse perspective. First of all, to do all these work, I need data experts, and each and every time if I don't have a DevOps or I would say a reproducible environment. Okay. Other thing is every source is different from another source. So depending upon the value you want from that particular structured, unstructured, semi-structured data, I need to have a different ETL process for that. Similarly, I will need a different components for that. So that is what I'm writing here. Data from source is available in various formats. Standard ETL process varies based on destination or consumption system. Similarly, if I have to implement this model or data model, there are various servers and implementation, which is really a tedious process. If any one particular function I missed out or I messed up with one function, even one simpler configuration, my future chain is all faulty. So that is the complexity the modern data warehouse brings while we do the analytics on these components. Okay. Similarly is the orchestration part. Everything is done fine, but now my data needs a sync, a fresh data every time. Okay. So I need to make sure that this runs at a schedule interval. And if it is not for a schedule interval, if it has to be done at particular triggers, then those particular triggers should be automated. I can't really depend on the data experts and data engineering team every time to provide me the same repetitive task. So that is what we are bringing, the challenges what the modern data warehouse bring, and what we are resolving with the help of DevOps. Okay. So similarly, any manual implementation of data warehouse system will be an error prone. So these are some of the challenges which you see from these architecture diagrams, from these pipelines, which we are obviously going to face if we are not going to use the DevOps. Okay. So now moving ahead from why we need DevOps, let's look at how DevOps is really helping. Now let's go even deeper to see the complete structure of DevOps. Now, previously, what I've shown was just a block diagram. Okay. But now let's drill down deeper into the development part. Okay. So now each one of you who are actually building those systems, okay, they have their own sandboxes. It can be your own machines. It can be on cloud, whichever way you are comfortable with. You can work independently. Okay. With the DevOps process on your own machine. What we want you to have is one particular centralized repository, or I would say any particular repository which has a branching system. Okay. So what we do is a developer along with one particular branch is given to that particular developer. He does his own work, and actually depending upon his implementations throughout, he actually does that work and provides the this his work or her work to that master branch. That means with the help of this particular git based branching workflow, what we are trying to bring here is every independent work we are capturing, and with the help of PR is nothing but the pull request. We are getting that validated that yes, this is suitable for us to bring it to a master branch, so that we can actually build the value, or I would say build the packages out of whatever you have done locally. So that is with the help of the build pipeline, that this symbols is for the Azure pipelines. Okay. So we are doing the build part of it, and we are actually bringing some artifacts out of it. So this can be anything depending upon the source which you are trying to bring in from the developer ecosystem. Now, this is available to us as a reusable component. How do I deploy it exactly the same way? And what do I need really for that to be deployed, that package to deploy? Obviously, I need some services so that are available in dev, stage, and prod. And if you see the symbols, this is Data Factory, this is Databricks, this is SQL warehouse or dedicated pools, whichever you can talk about. This is again the data lake generation 2. So there can be n number of services, but for representations, just to make it in sync, just shown you these particular different stages and the services which you need to have before I can actually build that. So again, with each of these stages, what we are doing with this pipeline is deploying these stages automatically using DevOps. And once this deployment is done and we do the check that yes, it is available for us, then we can directly pull this out on the data way, the way we want to pull the data. Okay, and run while we deploy, we can run the engine, what we call as a value pipeline within this particular dev environment first, and make sure the data what we are trying to derive right from your source to destination goes through that pipeline. That means whatever the cleansing has to be done, whatever the bad data has to be gone out, and the good data has to go on to business, everything is taken care in form an architect, so that while you move towards the staging, you do only the integration and the functional testing. While you move towards the production, the environment is completely locked down from any changes or any incidental changes which can bring the production, or I would say that system down. So that is how the complete data warehouse works end to end. And if you see the value, the Azure CI CD, what brings in, each and everything is replayable. That means from right from a developer environment till deployment or bring the value to the customer in form of dashboard, everything can be reproduced kind of the way we have the DR. Okay, and also the developers who are using this particular source, or whether they are building a new system or whether they're fetching the data from IoT or any particular industrial manufacturing, they are able to actually provide their input without any dependency on other systems. Okay, not if once this particular setup is done, there is no need of any particular expert unless and until some issue comes up. Okay, again drilling down deeper into this on the packages, I think this will be too heavy for you at this point of time, but for a representation perspective, I just want to show you that how this will look like. Okay, and what kind of the work you are going to do. So this I have already explained you from the build part. Okay, so this is the sandboxes of the developers. Now the way I said, we need some way to represent our data. So that is the reason we have made a first of all a structure which is kind landing, interim, malform, and this is nothing but the libraries which where we will use the Python. Okay. Similarly, for us to actually work on the development workspaces, we need some notebooks which will do the setup and the analysis on top of that. Okay, so each of those notebooks or whatever the program structure which we have in our mind, everything is has placed in respective workspaces. So again, bringing back to whatever we had, is this is very detailed. Okay, of what we are going to achieve out while using DevOps for modern data warehouse. So if you are looking at this particular structure, think of if you have to really deploy this on your own on each and every environment where there is no replayability of those particular structure, and depending upon you are seeing, and there are a number of services running here, whether it is what kind of data you are fetching, what kind of the source it is, it all changes quite often based on what the end system is and how you're actually fetching that particular data. So this keeps on changing quite often based on the data warehousing or analytics which you are running, whether you are going for a descriptive, whether you are going for diagnostic, whether you're going for prediction, or you're going for prescription. Based on the basic of these four use cases, you will decide what are the components you will need and how we are going to automate that. This system can be simple based on data you want to derive. It can be very complex, even going to machine learning or even going for the data scientific workflows as well. Okay, so that is, this will give you the brief of how the modern data warehouse will look like. Now, whatever you see here, I have just kept a native tools, whatever we have been using here. Okay, so whatever you have been seeing here. So these were the some cloud native tools which you have seen from modern data warehouse, right? So data factory, data lake, Azure Databricks, Azure SD Insight, and then Azure Snaps Analytics. So previously, if I have to correlate this with, this is nothing but a combination of various services. I think if you are already working on that, you already know that. But if you're joining for the first time and you haven't heard about these services, just want to give you some brief about these services. You can also run or search for this Azure Data Factory or the documentation on Azure as well. The purpose of this is to convert data, right? Data factories is the way I've shown you. Retrieve from one of the data sources and converts that, filter out the noise. Similarly, whatever you have been seeing from the pipelining that we can have in this particular data factory. So I am just giving whatever the concept which we have learned so far, a name to that with the help of the service which you are trying to implement. Similarly, coming to a data lake storage, obviously for us, the way heart of our system along with CPU and memory, we need some kind of storage to keep the data. Similar is here. Now to bring actual or give the value to it in a form of an hierarchical system where you can actually have the folder structure and hierarchy from what kind of the work you are doing. If you have seen, I think if you remember from the previous slide, what we are doing is landing, and then we were actually malform, whatever the malform data, we were separating that. Similarly, in interim, we were actually providing that usable data for end user. And there were other folder as well for the libraries and the Python. So there are n number of things where we need to have a folder structure. So this data lake storage is helping you from that perspective. Also, you can apply your RABC permissions, and if you are using a compatible SDFS file system, you can, or any particular cluster on Spark. So that also you can use here. Okay, so the end goal for this is for you to know what are the native tools which are available on the data warehouse. Okay. Similarly, the Databricks. The first thing which comes to my mind is the cluster, a massive parallel processing to be done for the big data. Okay, those are some common terms which comes to my mind when I see this particular Databricks as a solution. And why we need that, as I already told, depending upon the complexity of jobs, it is not be possible for a symmetric multiple processing systems, that is a single system to process everything. Also, if we want to run those queries in parallel and there are different jobs, different pipelines running, we need a big compute which can do that heavy lifting for us. That is the reason we are using Databricks. And even if we want to customize this further or move away from the platform as a service, the other option which you have is the SD Insight, which I have here. Here in SD Insight, what we are trying to do here is, we say suppose you are having running very complex queries. Similarly, you want to bring your own application logic, your own way of integrating that particular data in a hybrid way. Then you can use the SD Insight services, which is nothing but a kind of an infra as a service built by you for that particular purpose. Okay, so this is completely customized to your own way of doing a modern data warehouse, where, and depending upon the use case which you are trying to solve out, it should always align to your business, right? Then only obviously you will be to do such investments where obviously the efforts are more, but the value or ecosystem, depending upon your own competency or industrial customers which you may be having, depends upon that. I think they will be using either SD Insight services or the platform as a services which are dependent on the Snaps Analytics or the Databricks. Okay, and one last point on this is from an Azure analysis services. Now we have seen this while we are using a SQL reporting. Similarly, we have seen the SQL analysis services, but here this is purely from the cloud as a service. It may not be possible to do everything whatever you are doing with on-premise, but most of things which it is able to do from the dashboarding, from the reporting perspective is shown here. Okay, similarly, you can even read out for the analysis services. This will give you all the like whatever you have seen through in the past from an on-premise, like SQL data warehousing, the analytics way, the way used to produce the reports. Okay. Similarly, while we will have seen the OLTP, that is a transaction systems. Similarly, you can see how the OLPA systems works. Okay. So analysis system is purely built on that particular thing. Okay. So whatever the queries, it may be complex, it may be simple, and how you integrate with the data sources. Again, Azure Snap Analytics is a combined services which brings the data factory, which brings the backend data generation layer to in a one particular service, along with the Power BI dashboards and the engine, or I would say a compute of Databricks, or from the massive parallel processing in that one particular service. So based on whether you want to use a platform as a service, Azure Analytics or Azure Databricks, or if you want to design your own Azure SD Insight right from scratch, you have to build that particular system.